It is my pleasure to introduce to you two dear colleagues of mine from UCLA who teach with me here at AUD. And I'm going to introduce them both at the same time. I don't know if you decided who goes first. Laure? Okay. So I'm going to just introduce everyone and then we can get started. So today we have two female speakers, Laure Michelon, and she's a founding partner of MMR. I hope I said your last name right. You can correct me. She's a lecturer at UCLA Architecture and Urban Design and a creative and architectural technologist based in LA. Her research and practice focuses on digital simulation and algorithmic mutations. I hope she's going to explain more what algorithmic mutations are. With specific interests in infrastructure systems, climate engineering, machine vision, and fashion. She has taught at SciArc, Kent, and the AA Visiting School in Seoul, and has worked as an architectural designer at Studio Kinch and at Euler & Wu Collaborative, and as an energy analyst at CSR Lead and building facade analyst at UMAC Tetra Tech. These are two of her professions which I was recently made aware of during a conference, and I was very impressed by the diversity of Laure's professional practice. Her personal work has been exhibited in galleries throughout LA, including Wohnzimmer Gallery and Tetrapod Gallery, and she has curated multiple shows in collaboration with Super Collider. Welcome, Laure. I see there is something additional about you. She has a postgraduate Master of Science in Architectural Technologies from SciArc, where she graduated with distinction, and a Bachelor of Science in Civil Engineering from Columbia University. Then I continue with Yara Feghali. Yara is a French-Lebanese architectural designer working at the intersection of architecture pedagogy and transmedia and immersive technologies. She is a member of the design faculty at UCLA AUD and the creative director of Folly Feast Lab with her co-founder Vivian El-Khmati. I'm not sure if I said this right. And based in Santa Monica, California. Vivian is a Lebanese designer and a technology director working with virtual reality, storytelling, and artificial intelligence technologies. Through world building and storytelling, both Yara and Vivian design immersive and interactive experiences, applications, software design tools, and games around queer identity, sustainability, and technology. With Folly Feast Lab, they are committed to designing fantastic experiences that are aesthetically engaging and that they are technologically performing. Their XR work has been part of Fiber Festival Amsterdam, Architecture and Design Museum LA, LA Forum, Ars Electronica in Austria, Thyssen-Bornwitzer Gallery, Contemporary Academy in Austria, AD Magazine, Refest Culture Hub, Siberia Playground India, and she has been in XR2C2 Cannes, which was really, I think, a great experience, Onassis ONX, Cal Arts Visions in 2030 Festival, MU Hybrid Art House, ZKM Germany, ZKM, and Pompidou in Paris, Art Science Museum in Singapore, like a long list of exhibitions and engagements. So I'm really excited to welcome the two of them. They do phenomenal work, both professionally, but also academically. And I hope you can put together a lot of really good questions for them because they will stay on afterwards for a little conversation. So thank you both for being here.
Thank you for that. It's always awkward to listen to your bio, but
I'm so happy to be here. Hi, everyone. My name is Laure Michelon, and as Yulia said, I'm a creative and architectural technologist based here in LA. I have quite a lot of interests, but tend to focus on infrastructure systems, geoengineering, machine vision, and fashion. As Yulia kind of hinted, my background slash context slash how I got here is not the most traditional pathway. So I like to kind of go over it when I'm explaining my work because I do think it gives some interesting context to my work. I started this in COVID when I was just diagramming out my work in order to find connections or like overarching themes, which projects led to which jobs, or really just, how did I get here? So you'll see, I love diagrams. I sort of think that my work fits in 4 main categories. These categories are very fuzzy. There's a lot of overlap, but as of right now, they are academia, research, design and consulting, and art and curation. So in my academic category, as I said, I have an undergrad degree in civil engineering from Columbia University. I chose civil engineering because I was good at math and physics. I liked bridges. My senior year at Columbia, I worked on a research project looking at using shredded plastic from old computer parts as aggregate and concrete, which was actually fun, even though I was just using the shredder and helping mix for the slump test. I wasn't actually doing so much, but I still found it interesting. I got my master's in architectural technologies from SciArc. I then started teaching in that same program, as well as later on an undergrad thesis studio. And currently I teach here, UCLA AUD in the postgraduate technology studio. For my research category, when I worked at an MEP firm, GlueMac, I was a part of their high performance building group. You can kind of see some of those projects on the left-hand side. I worked on projects that were scraping geolocated Twitter and Reddit using sentiment analysis to graph disinformation across the internet. I worked with the American Society of Civil Engineers designing a video game. It was really just doing the math for the future of a city that would have 50 million inhabitants, trying to see what would that mean, like how much food would that require, how many bus stops, how much actual housing, in what densities, how much energy would it require to run, things like that. And I've been a part of a couple hackathons. Maybe my favorite one was looking at bias in the data sets used by a couple of recruiting firms that were leveraging AI to help find people jobs. In my design and consulting sheet, I've worked as an electrical designer on projects like Disney Shanghai and the Wilshire Grand, as an energy analyst and energy modeler, sustainability strategist who focus on the building facade. I've worked freelance, most of which is using like emerging technologies like machine learning and some AR real-time data on anything from a weather app to accompany an art installation, an Eve's Tumor music video, or an open-ended zero-player simulation game powered by artificial intelligence. Since graduation from SciArc, I was working at Studio Kinch until Casey Ream, Galileo Morandi, and I started Studio MMR about a year ago. And under the Art and Curation tab, I have, as was mentioned, I was a Super Collider ambassador a couple of years ago, getting to curate and be in a couple shows around LA, but also one of which that I'm going to show a little bit of later, which was at Biosphere 2, which if you don't know that building, I won't get to talk about it that much, but like it's awesome. We can talk about it later if you want. I was the guest curator at the A&D Museum of the show We Are Here, which was the inaugural exhibition at their new location. Currently at Studio MMR, we're working on a piece that'll be interactive,
showing at Getty PST later this year, so should be fun. But again, looking back at the diagram, it's like I'm interested in systems. So like how might we interface with these systems or disrupt current ones? And that system might be like seaweed or algae production, brownfield sites and soil remediation, machine vision surveillance and surveillance. There's a range of things. So for some of the projects, like on the x-axis here, you can tell it's a different diagram. Like I didn't lie when I said I love diagrams. It's just like I think how I think, but whatever. So on the x-axis, I have like the scale. So zoom in, zoom out. On the left-hand side, for zoom in, that's probably face or body scale. Right-hand side, zoom out, that's, you know, city, urban scale, occasionally exoplanets. And then y-axis is info to noise, which should actually be signal versus noise, but bear with me on that one. Which just really just means how much data, research, and reality is interjected into the project. Like how speculative is it? How based in fact is it? But today in this presentation, I'm going to think about two scales, the zoom in and zoom out. So for the first one, zoom in, I'm looking at my machinic reflections piece and some student work from my proxy faces seminar. So according to machinic reflection, do you look like an artist, an educator, a conspiracy theorist? Do you embody these classifications reflected back at you? This machinic reflection is both a version of reality and a simulacrum. Seeing ourselves through the eyes of this reflection lives in the uncanny valley. This classification reflects an unknown representation of us back, one that is too quick to be non-negotiable and one that is based on a logic that we do not see. Image classifiers, object detection, and facial recognition are used in local police departments, security companies, the military, tech companies. These algorithms exist and are being implemented in a variety of classification models today. Do you attempt to change, distort, or manipulate it? Do you hide from it? Do you embrace it? So starting this project, I scraped LinkedIn for 400 profile images of self-categorized careers. So I have 16 different categories of careers, then going through LinkedIn trying to find people who claim to be that, except for conspiracy theorist, which is not a career, I think, on LinkedIn. So that's the only one that wasn't from that. And then trained a classifier on it. And so viewers were asked to look into the vanity mirror and then get classified in real time. They were then kind of confronted with the snap classification that they could attempt to hide behind masks generated from my own face or just accept their classification. This was really fun to see people's reactions. So some treated it like a fortune teller, begging their friends to come over and be like, what are you going to get? What is it going to say that you are? Others were very offended by what they got. I think the first person who looked at it that I didn't know got lobbyists and demanded for me to explain why. But like, for me, that was kind of the point. These models are already classifying you based on readily available data on the internet. So how does that make you feel? This is also from when my parents were testing it out, which I thought was fun. So building off of that project, I taught this course spring 2023 here at UCLA. This course investigated the classification machine learning models as well as explored a variety of mask making techniques that might help us to distort the classification. So these masks or proxy faces serve as a type of tool or prosthetic through which the user could disrupt their classification that was originally deemed by the model. Students were using YOLO V8, which is the you only look once classifier and detection model, and then designing masks that would somehow change the reading of their face. They could either increase the percentage human, or they could decrease or change the reading. But if they decrease or change the reading, it also still had to kind of look like a human face to us. So you couldn't just have a mask that looked like a bird and then get classified as a bird. Yeah. Move forward. Okay, there we go. Then they also wore their masks out in public, which was just kind of fun to take the projects out of the classroom and into the real world. I'm just going to move on to the next one once we get to my favorite photo of Manon on the bus, because it's worth it. I also didn't give, they didn't have a specific context. This is the one. I love it. They didn't have to take their photos in a specific context. This is really up to them and like the world that they had built around their masks. And then actually that one in the bottom was Dewani, who was the only one who decided to do percentage more than human, which was fun. Okay, so now we're going to go to the opposite side of my scale and we're going to zoom out. So whether you like it or not, we are already surrounded by multiple layers of technological and ecological infrastructures. Researching these hyper-legible mega engineering projects isn't about some fantastical cyberpunky sci-fi utopian city, but instead about a genuine curiosity about the complexity of systems that surround us. So this first project is Neural Net City, which was shown at the Seoul Biennale in 2021. So this installation explored the transformation of the existing Seoul City plan based on extrapolating currently proposed or already implemented smart city technology. The specific focus of this transformation will be how digital forms of governance and perception allow us to rethink traditional boundaries within cities. These boundaries include between urban and wilderness, public and private, and the different program types within the city. As digital sensing and governing become more prevalent, what sorts of alternative thresholds can be established in place of traditional city designs? The installation was comprised of two main pieces, a 1 to 2000 mixed media master plan model and an interactive projected media piece that incorporated 3D sensing and 2D cameras to simulate contemporary smart city technology. This goes on for a while, so I may wait a second. See if we can skip that. This was the interactive pieces, grabbing people's faces and then really morphing them. That launched a whole obsession with distorted faces that led to many other projects, but okay. I'm not going to spend too much time on this project because I'm still very much working on it, but I started by mapping the brownfield sites, which are just like contaminated sites around the arts district in LA. So these might have pollution from what was previously there. It could be heavy metals, oil, petroleum, lead, really anything carcinogenic. And then planning to use a combination of myco, phyto, bioremediation, so a natural stack of remediating layers that include mushrooms, plants, and microbes to naturally clean out the soil instead of the process of just physically removing the soil offsite. This would be a way to kind of plant these bioremediation pods to clean it in situ. So some more student work. This is from winter of last year in my distorted cartography course. How do maps shape our understanding of the world? How does this world get coded in the maps, diagrams, and data dashboards? The historical continuity of our cartographic culture parallels the rapid change in mapping technologies and forms of visualization. So using archival and technical research, a range of machine learning models, intelligent agents, students were analyzing, representing, and manipulating infrastructure at an urban scale and created a historically situated, technologically literate, and data-driven representation of remote and extreme climates on Earth. The stack was presented as a digital collage of layers, and as well as a physical representation of their map that had pop-ups and explanations depicting the systems and providing narrative and numerical details. Also, this is funny because that's a photo of Draw, who's here. I saw you like a couple minutes ago, so thanks. Appreciate that, Draw. Okay, so I mentioned in the beginning, when I was a super collider, I got to curate and then be in a show at Biosphere 2. And this project translation was projected on the North Lung during the Analog Astronaut Conference. I'm actually going to mute it though. That's like, we're not going to miss anything. It's like the binaural beats. It's, you wear headphones, it's supposed to help you focus. So, maybe I'll keep it. I don't know. Okay. Climate change is essentially a pattern or a series of patterns drawn from planetary scale data collection that is synthesized and interpreted through a climate model. By the time the information makes its way to the public, it's already been translated through numerous phases and filters: sensing, dataset collection, climate modeling, IPCC condensation and filtration, and media translations. As our culture becomes more dependent on the visualization of information, it necessitates a reinterpretation of this information. This piece emphasizes both the success and shortcomings of the language used to write original documents. The act of translation suggests an alteration, a change in the given language's form, condition, or nature, often with the intention to explain the original subject matter in terms that can be more easily understood. By translating the IPCC climate report into visuals generated by a variety of neural networks, translation aims to adjust the way we can be informed by the data in the report. These trained machine learning models reinforce and reconstitute known imagery through the bias inherent in the curated dataset, producing visuals that broaden the report's ability to be understood and serve as a broader call to action. So in general, no matter the scale, I'm interested in ideas related to automation, architecture, design, and engineering through design experimentation with an emphasis on machine learning algorithms and how they might open up design to elements that are either beyond human perception or are currently downplayed in the design process. So to wrap up, I'll say that from climate change to surveillance to densification, the speed and scale of architectural transformations calls for an expanded conceptual framework in which the automated design processes allow us to question received classifications, pushing the design toward a more complicated, fluid, possibly chaotic, inclusive design proposal. So that's it. Thank you. Up the transition.
We're good? Okay, great. That was great. I love the last piece, Laure. It's the first time I see it in full. It's really, really, really cool. Very smart. Hey, everybody, I'm Yara. My practice is called Foley Feast Lab. And the question I usually get when I present to architects is, okay, cool, but how do you do that in an architecture school? So what I thought I would do today is I would start with a project that I was doing in my practice, and I'll continue with work that I've only done at AUD. So you get a bit of sense of, I think, what an architecture education is, which is a really large scope of design skills that you can apply in different disciplines. And I think Laure and I would agree that we understand architecture as a disciplinary that becomes only greater through transdisciplinary collaborations. And this is a bit where I would place my work. And if you see here, there's two little cubes. One says Foley Feast Lab and one says UCLA AUD. So whatever work is on the screen, if you follow the cube, you know what it's part of. Thank you, Julia, for the introduction. And this is important because it's a bit where I come from, but also what inspired me and why I do what I do, maybe. So I'm born in the Middle East, and my partner is born in Saudi Arabia. And we both studied in Lebanon, then we moved to Germany, moved to France, moved back to Lebanon, moved back to the US. And really, our work is all of that together. So we run Polyfeast Lab. And what we do is that through world building and storytelling, so stories and building worlds, we design immersive and interactive experiences, application, software, design tools, and games around queer identity, sustainability, and technology. So these are the topics that we're interested in. And I think because I'm using these terms, I think it's important to describe what immersion and interaction is on a very basic level. And when I speak about interaction or immersion, I mean spatial interaction and immersion. So interactivity, if you want, responds to the question, how much am I doing? And meaning where I am on the spectrum or where you are on the spectrum from being a passive recipient to an active player. And interaction could be you liking a video on TikTok. It could be you playing Monument Valley, a game, or Sims. Or being a passive recipient would be swiping through images, exploring the VR world, VR means virtual reality, being able to see infographics, but not really doing much other than looking. And when you get to the active side, is you're looking at stuff, but you're also able to interact with them, right? So you can be in a virtual reality space and you can change the color of the wall. We could change the beautiful green neon color of our walls here, but you could interact and decide things in the space. And immersion in that sense and spatial immersion answers the question, how deep do I want to go? So where am I between the physical and the virtual, okay? So it's not between the real and unreal, it's really between physical, something that I can touch, and something that is virtual, that is digital. So it could be, you could be immersed in a novel, right? When I read a really great book, I'm immersed in it. It could be binging your favorite series. Or on the lower part of the spectrum, you're immersed through your smartphone screen, tablet, or laptop. Or you could be playing Pokemon Go in AR, right? Using the Amazon AR app to check if the couch fits in your living room. Or on the highest part of the spectrum, you're immersed in virtual reality, visiting the Golden Gate Bridge through Google Street AR. So it's really on these two spectrums that our work exists. And it forms this diagram from not interactive to interactive, not immersive to immersive. And I'm not going to read all of that, but the side we're really interested in, and you can see the little cube up there, is being in the fully immersive, fully interactive space. So you're inside a space that is fully virtual, you're fully immersed in it, and you're able to change things around you, okay? And I think the main question that I come back to and keep asking myself is, what can architects learn from video games? Let's see if we can understand through the little presentation what we can learn from that. Virtual herbaria is a residency we did in the south of France in Cannes. You can see the beautiful weather and landscape. So it's an app that was designed for the French Riviera. It questions the way we visualize and utilize large data sets, archives, and library. And what it basically does is we went into a herbarium. A herbarium is a sort of archive library where there's pressed flowers. You know, when you're a kid, you put a flower between your book, you press it so it dries, and you keep it as a souvenir. A herbarium is a place filled with that, and a lot of scientific description of what that plant is, where it comes from, where it grows, and so on. And the way these herbarium exist today is as physical spaces, as you see them in there, but also as digital spaces. So this is the online herbarium of Joshua Tree, not so far away from here. And you can visit it online and you can click on this button and you get that data sheet where you can see the plant press and so on. So what we did is we went through the coastline of the south of the French Riviera, and we looked at every kind of botanical garden that exists there. And we documented around 20 more than 20 different plants. So you can see on the left, the pictures of the actual plant, and on the right, you can see the 3D model generated to look like that plant. And they come with working on technically you work on the texture, the geometry, the lighting, the movement, and so on. And they become these elements that you can augment in real life. So there's an app, you can download it on your phone, but it's geolocated. So it means that it only works in the French Riviera. And you can see that you put a tablet onto a space, and then this huge flower digital flower appears, and you can interact with it through your tablet. And you can see this woman is sitting next to it. And it also comes with a VR element. So you can put the headset on, the virtual reality headset, and you can experience this digital garden. I'll show you a little recording of it. So that was a work where we were trying to discuss sustainable goals for the EU through that little application for tourism that really emphasized the importance of biodiversity and the flora of that region. We also did a version of that for CalArts, a bit north of LA. And for some reason, the plants got a bit punkish, but maybe that's what the heat does to you in LA. And we also displayed it there. So if you download the app that's for LA and you're on CalArt campus, then you can walk around it a bit like Pokemon Go. You can catch these digital flowers all around you. And this is where you remember when I told you, people ask, okay, architecture, where is architecture? Okay, so we'll come back to how that gets included in our curriculum at AUD and why it makes sense to learn these tools. So this is virtual herbaria, so it's the same kind of topic, and it really centers around, it's a 4 or 5 day workshop, so it's pretty quick, and it teaches students how to do all of that I just showed you. So we learn how to model, do texture, lighting, animation, and so on. And we start with the same background, but we look at Joshua tree, so we look at the closer flora. We use AI to generate images of things that would look like cacti, like succulents. And then what we do is we 3D model these, and this is how it looks. And you can see here, if you look closely, you can see there's the technical sheet, but there's also an augmented 3-dimensional element in front of it. So in augmented reality, the students 2-3 days in are already doing these apps and seeing their models animated, lit, and so on. And then we go and we put it in a digital environment and we do a virtual reality game version of that, where the goal is basically to walk around and to plant trees. Okay, too loud. So where you go around and you plant trees. And of course, they're trees, but they could be anything that belongs to something like bricks. So you can build a house, or you can build an urban center, and so on. That was fun, right? So, and the kind of same techniques go to different classes. So this is also another class done here, the Collaborative XR Lab. This is a metaverse space, so it's spatial, where students went in and designed 4 different users. So we had the traders, the dwellers, the explorers. So they designed different people that would live in this world. It's really cute. They designed all of that. So each person has their own world, their own object. So you can see the little merchant down there. He's on a little boat with fruits, and he has his own peers. So you design the character and the world that comes around that character, and then you're able to go into that space using, I'll show you the video. I think it's playing slowly. But you can see in a bit, the video that she's in VR, but that's her. She's a little ramen bowl. She's a dweller. Wait a second, there we go. So you become these avatars and you live in that world and you build things together. You can see she's walking around. Someone has left a mess before they left the world, but you can pick up, depending on your character, you can pick up different objects and you can build like a bazaar. If you're a trader, you can build entertainment. If you're one of the tourists or the explorers. So we really learned like the tools, how to design all of that, and how to make them interactive. So this, I would say, is on the spectrum of full immersion and full interaction, because you can change the space. You're going to see there's a little menu that pops out. They can choose their object, their color, their size, and they've chosen to put donuts in, but you can choose to put anything you design in it. This is a different one. It's called 2D Play. It's a platformer game. The technical word is platformer game. The cool word is it's a Mario game where you run around and you try to save Princess Peach. So it's the same kind of mechanics, but we used it and we're like, what if we do a platformer where you run across architectural sections? So we looked at really cool architectural section and we're like, okay, we're going to use this software to design a game where you run across an OMA section and we see what happens. This is a platformer. And we have little coins around and so on. And you can see this is some of the examples. So Supermatism, of course, is looking at Zaha Hadid. So you can see their icon for the game and then their platform game. You see this little green guy running, trying to get the right coins. You can see Utopia is around Toyo Ito, Creme Brulee is around Brulee, and so on. And I'm going to play one version of it. And we also did a metaverse. This is what you're looking at first, like an arcade game where you can get in. So they design these spaces, how you inhabit, how you design a corner of a gaming arcade, and then you can get into the 2D platformer game, which is basically an animated drawing that you're playing on. Let's give them a few seconds. Yeah. So you can see a little demo of their character running and losing through the section. And then at some point you hit different trigger points where you get a question that you need to answer correctly in order to continue the game. And we run this during Rumble. Rumble is our school-wide end-of-year exhibition. And every student were like behind teachers looking at, are you going to get this answer right? Are you going to know what Shumi did in, I don't know which year? So it's really supposed to be fun and entertaining, but also we learn all of these techniques and we learn about all of these different architects and we run through sections. Another one is called, that's before last project, is called Santa Monica. We did this in December of 2023, so a few months ago, and we designed a choose your own adventure game. Choose your own adventure is basically a game where you get asked a question, does Samantha want to eat the apple or the banana? And depending on what you answer, it tells you go to page 24 if you want an apple, go to page 20 if you want the banana, and it changes the story depending on what you choose. So for us, it was really like an interactive component that we were like, okay, what if we do that, but urban planning? And I can see some of you wink, wink in the room that were part of this project. It was a really cool group. And we just decided to design a game for a studio. And it turns out crazy, but fun. So you can see, and we exhibited at Skill Screen, and you can see some of the models on the table, and I'll play a bit of the gameplay. But the idea is we're looking at an urban block in Santa Monica that you can see up there, 3 versions of it. And depending on the decision you take as a community, then the block looks differently. So if you decide that actually you want to get more, you want to generate revenue from that block, then you build a lot of housing. If you want to be eco-conscious, then you build a lot of parks. And there's around 16 different iterations that you can get as a result, depending on more than 100 choice that you do. And this is called a narrative branch. So this is what the students designed, which is basically the answer to every question or every possibility, depending on what you answer. And this is the crazy analytics boards of what does it mean if you have this result? How much like community points are you getting? It's a bit complicated, but look at there. This is the site as it exists now. And this is the gameplay. So it asks you a question. You can see up left, the block has added a lot of green spaces to the city. This is one of the final screens. It tells you you did good. But if you look at the lower right one, it says this pedestrian park and wildlife center have attracted a lot of tourists to the block, but they don't generate enough revenue to cover their operating expenses. As a result, Capital Development Corp offers funds to sponsor the operating expenses of the pedestrian park and wildlife center in exchange, this is evil, in exchange for adding a privately operated sports sanatorium or water park to the block. Do you accept this offer? And this is where the students, but also our guests as players, had to answer, I accept the sports sanatorium or I accept the water park. So we don't have a choice, we needed the money. So I'll show you a short video of what that looks like. And before I do that, what you're going to see in the background is one loop of the game. So someone choosing and playing the game. What you see up left is a map that is usually on the wall. And what you see down left is the game board. So it's a 3D model of that will interact at the same time as the decision made. So the first question is, who are you? And then it gives you some choices, you do your decision, and you can see that you choose something, and on the left, you will see something will get added to the sides. And then you get a preview of what that wildlife center looks like. So it's a fully operating game designed by an amazing group of students. I see Kinemi in the room. So every choice you make, then you build something. So this is a back alley path, and you can see on the left the physical model and the map being put. And there's 16 versions of that. So every time you answer a question, there's a different, and you can play it online. So I'm gonna go a bit quicker, but you can check it out and play it online. It's pretty cool. The last project I want to show, we just finished that a few weeks ago, the axonometric query, and it was really a game where we wanted to take the platformer, but make it more spatial. So the idea was that students build these insane models that you can see in the back. And we use a camera on our laptop to play a character that moves through these models. Okay, so these models are real, physical, sorry, not real. They're physical, everything is real. It's physical, it's in the space, and then we point a camera at it, and on your laptop, you play the platformer. And the point is to get from one level to the other, and you can see 8 models, 8 levels. If you look at each of them. Okay, didn't have a lot of time to choose the soundtrack, but if you look at each of them, you can see this little character walking around, trying to make its way from one side to the other, and triggering different things on digitally that don't exist physically. So it's working between digital space and physical space. And you can see using this type of technique could be pushed to a landscape plan or a master plan for urban planning, or on your final model, you use that to represent circulation or egress. So all of these techniques, even though they're used on, oh, I wanted you to see the end, wait. All of these techniques, even though they're used to do flowers and games and sections and models like that, and a choose your own adventure game, they're really tools and techniques that could be used for anything else that is more directly architectural. But I think what's great about an architecture education is that it gives you all those skills that you can cross with other disciplines and be able to talk to different people from different realms and collaborate and produce work together. I'll just give it a few more seconds so we... Come on, you can make your way on the other side. So you would say each level and each switch has all the amazing, brilliant designers and students that made it possible. This is us way too excited to play the game. And we have a joystick and we're trying to make our way around. being guided by how we should move and where we should go. And you can see digital portals and things that are overlaying physically on top of the physical one. And this is the size of the models, what they look like. Also, amazing students are in the room today. We're part of that club who made these beautiful things possible. That's all. Thank you so much, and let's have a conversation.